For us, this is Unit 4, Lesson 3. Okay, so this is parallel perpendicular lines. So going off a slope, we're going to talk about two lines now that can be parallel perpendicular. It's really just straightforward. You either know it or you don't. Okay, but I think most of you here might understand if I have two lines that are parallel, what do they have to have? The same slope. Boom, you already have half the lesson done. Okay, when you're looking at a line, they have to have the same slope to be parallel. Because of the same slope, they have the same steepness, and they'll never cross. Okay, but if they're a little bit different, they're going to eventually cross. Okay, so parallel is the easy one, means same slope. Perpendicular is a little bit different. Let's just take a second, though. What does perpendicular mean mathematically? Good job. 90-degree angle is what I was looking for. Logan hit it. So perpendicular means that you have them cross in a way that all the spots there are 90 degrees. That makes it perpendicular. Okay? All right, so let's go ahead. You guys got that? So let's look into the rest of it here. Okay, so in early mathematics on a grid, actually, I don't need to do these. We don't need to take care of these. Skip these warm-ups. I skipped them yesterday because we can just get right to the actual task at hand. Okay, parallel and perpendicular lines. Make this video short and sweet. Okay, so recall the slope of any line segment within a line repeats the slope of the line. Consider two lines slope with M1 and M2. Therefore, if the lines are parallel, then they have to equal each other. If they're perpendicular, their product of the slope has to be -1. So it's a little bit weird, but if I said 2/3, what would be perpendicular 2/3? Then it would be multiplied to get -1. Kind of tough. Close. Flip it, switch it. Flip it over and switch the sign. So if you're saying, well, where's the -1? Well, the -1, okay, is 2/3 times -3/2. It's right there. When you multiply those two, they equal -1. Okay? Let me ask you another one. What would the perpendicular slope, if I said your slope is 4, what's the perpendicular slope to 4? Negative what? -1/4. People forget this is over 1. So the perpendicular slope is -1/4. Flip it, switch it. Okay? To find perpendicular, you flip the fraction, that's the reciprocal, and you switch the sign. So it's the negative reciprocal. And right here in your notes you can. For perpendicular. Perpendicular is a negative reciprocal. Is there any questions with that? So you flip it, switch it. So let's try one more. If you have -4/3, what would it be? 3/4. Flip it from 4/3 to 3/4. It was negative. We switch it to positive. So it's not always negative. You can switch to positive if it already was negative. What that does is, okay, those slopes cross each other at 90 degrees. Because some people yesterday, which is a very valid guess, when I said, what would you do for perpendicular of 3? They said -3. They thought those would be the perpendicular, just opposite, right? Positive and negative. Well, look, if I graph 3, let's just do right here. 1, 2, 3 over 1 over 1. That's what 3 looks like, ish. Okay, well, 3x plus 1, because I missed the middle. Okay, if I'm doing -3, it would look like that. Can you see visually the problem? These angles are much bigger than these angles. They're not all equal 90. Okay, so that doesn't yield perpendicular. Perpendicular has to be the reciprocal flipped. Gives you a 90 degree, okay? So looking at that, consider the segment AC with a slope of 3/4. Right, the slope of the segment was parallel. Well, that's tedious. Be 3/4. Oops, I don't highlighter. This one would be 3/4. Right, the slope of line segment BF. Sorry, let me make sure I label here. This is GH. BF. if it's perpendicular. So what would it be perpendicular, Logan? -4 over 3. Good. Okay. All right. So example 2, they give you two slopes. They want to know, are they perpendicular, are they parallel, or is it neither? Okay, so to figure that out. So Ollie, what do you think for A? Ollie? Okay, they're not perpendicular. You can tell that because they're the same sign. Yeah. Okay. And how do they parallel? Because 1/4 and 3/12 is different, right? But how do you know they're parallel? Right, because this reduces. 3 over 12, when you reduce it, is 1/4. 3 goes into 3 once. 3 goes into 12 4 times. So 3 over 12 is another way of writing 1/4. Okay, no problem. What's that? I said Ollie, because I called for Ollie. Okay. Good. All right, Spencer, how about B? Perpendicular, parallel, or neither? Yeah, good. So this is 5 over 7, and this is 7 over 5. What's it missing? The negative sign. There's no negative, so that's what it's missing. Okay, we'd have to flip that. That's all. Okay. All right, we'll keep getting through this, guys, so we can get on here. All right, if the point 4, 7 in Q is the point 6 and -2, if the point P and the point is 4, 7 and Q is the point 6, -2, find the slope of the line segment. So how do we find the slope of this? We learned this yesterday. That slope formula, we have 2 points. So please don't forget that. That was just yesterday. Remember, we have to go y2 minus y1 over x2 minus x1, right? Y minus y over x minus x equals m. So in this case, -2 minus 7 over 6 minus 4, -9 over 2. Okay, so something parallel, that would be the same. So the slope, m is just slope, so that's not a new variable. So -9/2 to be parallel for part A. Okay, Josie, you want to take a shot at perpendicular? Flip it, switch it. Come on.
So that would be 2 over 9.
Don't hurt yourself. Okay, 2 over 9. Okay, flipped it, switch the sign. It's positive now because we had a negative. Is that clear? Is that good? That quiet time to start class, I think, is making us feel a little zonked out. All right. So triangle LMN has the coordinates -4, 2, -2, 7, 1, 0. Use slopes to show the triangle is right-angled at L. So if I just kind of draw this real quick, and I'll explain what they're asking you. -4, 2, so I'm right there. -2, 7. Okay, and then 1, 0. So they're trying to, we want to know if that's that's a 90-degree angle, which means that that's perpendicular. So what we want to do is we want to figure out what's this slope and what's this slope. They should be perpendicular slopes. So it's one of those all-inclusive questions. It would be a very good test question. Okay, because it makes you use slope formula. It makes you know what perpendicular is. It's 2 and 1. Okay, so I'm going to find the slope of LM first, right here. 7 minus 2. Get used to this. 7 minus 2. -2 minus a -4. So I got the minus there. Makes plus. 7 minus 2 is 5. -2 plus 4 is 2. I got 5/2 for LM. Can we understand that that makes sense? Because is this a positive slope or negative? This one's positive, right? It's going up. It's positive. We got a positive answer, so we feel good about our answer. The next thing you can do is you can say, okay, let's say you forgot the minus and minus. You would have went -2 minus 4. You got -6. You would have got a negative slope. So you mean like, wait, this is not a negative slope. Okay? So just kind of double checking yourself just by looking at the slope itself, whether it's positive or negative. Ln is going to be what kind of answer? Negative, right? It's going down to the right. So we got ln 0 minus 2 over 1 minus a negative 4. Are these perpendicular? They are. 5/2, negative 2/5. One more question. It's a little bit confusing, so please ask questions if you have any. Okay. All right, last one. We'll take a quick little break, and then we'll do the next part. So the lines have slopes of negative 3/4 and k over 5, respectively. So two lines have the slope. So negative 3/4 is our slope we're given. This one we kind of don't know because we don't know what k is. Find the value of the k if they are parallel and perpendicular. So what we have to do, guys, is negative 3/4 is what we want it to equal. So it's actually legitimately just that setup, and we solve. So what I did was, if we're given the slope negative 3/4 and k over 5, and we want these two to be parallel, then they're equal. Because parallel means equal. Now, concentrate on the task at hand. Ridge, what am I going to be solving for? K, right? So then what is your only problem right now? Nothing over here. What? Yeah, well, the problem is the 5, right? Because when we're solving, we're trying to get k by itself. This is divide by 5. So what's the opposite of divide? So we multiply 5 to both sides. Question, do I multiply the 5 to the negative 3 and the 4, or just the negative 3? Good, okay? Even in Math 20 today, they did that, and we talked about why that's wrong again. Because if you multiply to top and bottom, what's 5 over 5? You're not changing anything. It only goes to the top, okay? So your answer is, that's your answer. Negative 15 over 4 is what k has to be in order for it to be negative 3/4. And if you're like, that doesn't make sense. Negative 15 over 4 is not negative 3 over 4. You're exactly right. But watch. It's that over 5, right? We just solved for k. So when we divide by 5, are we okay if I write it like this? Right? That's the same thing. What do you do when you divide fractions? Okay. 5 times 4, right? What's negative 15 over 20? It's negative 3/4. So that means we got the right answer. Okay? I know it looks different, but we got the right answer. So we do the exact same thing for perpendicular, but we don't use negative 3/4. We use what? Positive 4 over 3. And we do the same exact thing. Times by 5. 20 over 3 is k, and that's it. Again, you can check that one if you'd like. I'll do it here for you quickly. So 20 over 3 divided by 5 over 1. 20 over 15 is 4/3. All right, so that's it for that one. That was quick.